Yes. Yeah, it's okay. It's okay. Person has joined. One person has joined. One person has joined. Welcome to new class. Today's class will be very interesting. Will be very interesting. I remain myself JAMB from Neotisa. From Neotisa, the best online learning platform. Today's class, we are going to look at factors affecting resistance of wire and conversion of galvanometer to ammeter and voltmeter. Let us wait for the next 3 minutes so that other students can join. Please, let's wait for the next 3 minutes so that other students can join. Okay. Our good students, please, let's look at this topic. Let's listen to it with all our minds. All our minds. Please. First, let's start with factors. Factors affecting resistance of a wire. Factors affecting the resistance of a wire. That's the first one we are going to look at. Then in the next 20 minutes, we are going to finish this so that we can go to conversion of galvanometer to voltmeter and ammeter. Factors affecting the resistance of wire. Okay, let's start. What are the factors that affect the resistance of wire? As we know, that resistance is an opposition to the flow of current. Resistance is an opposition to the flow of current. Resistance is an opposition to the flow of current in an electrical circuit. the opposition to the flow of current, that is resistance. Then we are going to discuss factors that affect the resistance of the wire based on the scheme of JAMB, based on JAMB syllabus. We won't go beyond JAMB syllabus. I won't look at velocity drift of what, of metallic conductor. I won't look at that. I'll just look at factors affecting resistance of wire based on JAMB scheme of work, which is not that hard. If you listen to it, it's very simple. Listen to it with all your might, it's very well simple. What are the factors affecting the resistance of wire? Number one, length of the wire. Length of the wire. This is first factors that affect the resistance of wire. Length of the wire. Number two, cross-sectional area. Cross-sectional area of the wire. Cross-sectional area of the wire. That's the second factors that affect what? Resistance of wire. Cross-sectional area of the wire. That's the second factor. Number three, we have nature of the wire. The nature of the wire. Nature of the wire, which is resistivity of the wire. Resistivity of the wire. Nature of the wire. Number four, temperature. Temperature. Take note of that. Temperature. These are factors that affect resistance of wire. Sometimes under cross-sectional area of the wire, you can see diameter. You can see the diameter of the wire. Diameter of the wire. You can see radius. Radius of the wire. Because I will relate these two to what? To cross-sectional area. I will relate those two to cross-sectional area. Take note of that. Factors affecting resistance of wire. We have length of the wire, which you can say thickness of the wire. You can call length of the wire thickness. 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 Thickness of the wire. Take note. Thickness of the wire. Thickness of the wire. These are factors that affect resistance of wire. Length of the wire, cross-sectional area of the wire, which I will relate diameter of the wire or radius of the wire to it. You can have diameter of the wire, radius of the wire, they affect. We have nature of the wire, then we have temperature. That I want to write now do not affect resistance of wire. These factors do not affect resistance of wire. What are those factors that do not affect resistance of wire? Number one, shape of wire. Shape of wire. This one does not affect the resistance of wire. Take note. Shape of wire does not affect resistance of wire. Take note of that. Color of wire. Color of wire. The color of the wire does not affect the resistance of wire. Take note. Color of the wire does not affect resistance of wire. Take note. This one, they do not affect resistance of wire. Shape of the wire, if the wire is in any form of shape. Position of wire. Number three, anyhow you position your wire, it does not affect the resistance of wire. Position of wire does not affect resistance of wire. Take note, another one. The current, the type of current flowing through the wire does not affect the resistance of the wire. Current flowing, types of current flowing through the wire does not affect the resistance of wire. Either direct current or alternating current doesn't affect. All these ones do not affect resistance of wire. These are factors. These ones are the factors that affect resistance of wire. These are the factors that affect resistance of wire. All these ones do not affect resistance of wire. Please write them down before we go into the formula that will relate there. Because I will explain each of them in the next 10 minutes. I will explain each of them in the next 10 minutes. I will explain each in the next 10 minutes. I want to explain each so that we can go to conversion of galvanometer. Okay, let me rub it off. Thank you. Please, if there's anything, you can comment, you can ask question, and subscribe. Don't forget to subscribe to our YouTube channel, please, so that we can give you the best. And also tell your friend, and let your friend tell his friend or her friend. Please take us to the world so that we can give you the best. Please take us to the world so that we can give you the best. Please. Let's continue. Let us take them one after the other. The first one, length of the wire. Length of the wire. Length of the wire. Write it down. Resistance is directly proportional. Proportional to length of electrical wire. Resistance of a wire is directly proportional to the length of a wire, meaning that increases as length increases. Meaning that resistance increases as length of the wire increases. The longer the wire, the higher the resistance of wire. The longer the wire, the higher the resistance of the wire. Resistance of the wire increases as the length of wire increases. And resistance of a wire decreases as the length of wire decreases. Meaning that if you have a long wire, the resistance will be high. But if you have a short wire, the resistance will be low. Take note of that. Number 2, the second one. Cross-sectional area. Cross-sectional area of the wire. Cross-sectional area of the wire. How does this one affect? Take note. Resistance of a wire is inversely proportional. Inversely proportional to the cross-sectional area of the wire. Cross-sectional area of the wire. The resistance of a wire is inversely proportional to cross-sectional area of a wire. Meaning that if the area is small, resistance will be high. Inverse. If the area is large, of the wire is large, resistance will be small. If cross-sectional area of the wire is small, resistance of the wire will be high. But if you have a large cross-sectional area wire, if the wire has a large cross-sectional area, resistance will be small. Take note of that. Take note of that. Take note of that. Then if I relate these two together, resistance directly proportional to length, inversely proportional to cross-sectional area. This is a joint variation. Joint variation in your mathematics. From here, we have resistance of a wire equal to resistivity times length over what? A. That means, take note of that formula. Resistance of a wire equal to resistivity of the wire, which is the nature of the wire. Nature of the wire. Resistivity. Nature of the wire. Resistivity of a wire. Resistance of a wire equal to what? Resistivity, which is the constant. Nature of the wire. Times length over what? Cross-sectional area. Take note of that. Where L is length of wire, measured in meter. A is what? Cross-sectional area, measured in meter square. R is what? Resistance, measured in ohms. Then resistivity. Resistivity. If you make resistivity the subject of the formula, if you make resistivity the subject of formula, don't forget you have your resistance times area over what? Length. Therefore, the unit, this is resistivity. Then what is the unit of resistivity? Ohms meter. Take note. Resistivity, ohms meter. Write it down. Write it down. Write it down. Ohms meter. Please write them down. 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 Oh, you've done that. Oh, you've done that. Okay, let's move. Okay, let's move. Let's move. Let's move. From here, let's move. Class, take note of this. Take note of this. Sometimes in question, area of the wire will not be given. You'll be given diameter of the wire. Sometimes it can be given radius of the wire. What is area in terms of diameter? Area is what? Pi square over 4. Take note. If diameter of the wire is given, they want you to calculate resistance. You are given diameter, you are not given area. They want you to calculate resistance. You are given resistivity and length. Use that diameter to calculate your area. Pi d square over 4. If radius is given, radius in terms of radius what? Pi r square. Take note of that. Pi r square. Sometimes you can be given the radius of the wire. They won't give you what? Area or diameter. They use pi r square to get what? Area. So that I can solve the question. Please take note. Please take note. Take note. Then, resistivity, nature of the wire. Nature of wire. Nature of wire. Nature of wire. Nature of wire. The resistance of wire depends on the nature of what? Wire. Some wire has what? Low resistance, while some wire has what? High resistance. Take note of this. The most conductive metals, wire, the most conductive wire in the world is silver. That means silver is the most conductive wire. or metal in the world, it has the lowest resistance. It has what? Lowest resistance. If they ask you in JAMB, which of the following metal can conduct current most? Answer is for silver. The reason why we don't use silver in electrical connection is that silver is what? Expensive. It's very what? Expensive. It's the most what? Conductive metal in the world. It has what? The lowest resistance. It has lowest resistance. Followed by what? Copper. Copper. This one has lowest resistance. Is the most conductive metal or wire. Followed by copper. Followed by gold. Followed by gold. Followed by aluminium. Aluminium. Take note of that. That is nature of the wire. The affect what? Resistance of wire. Silver has the lowest resistance. Take note of that. Lowest resistance. That means it has the highest conductivity. Since it has lowest resistance, it has the highest conductance. Take note. What is reciprocal of resistance? What is reciprocal? Quickly like that, use that. When you have resistance, the reciprocal of resistance is your conductance. Take note. When you have resistivity, the reciprocal of resistivity is your conductivity, which I will see explain here. I will see. We have impedance, impedance. The what reciprocal of impedance is what? Admittance. Take note. The reciprocal of impedance is what? Admittance. Write them down. Reciprocal of resistance is what? Conductance. Is there in your past question? Reciprocal of resistance is what? Conductance. Reciprocal of resistivity is what? Conductivity. Reciprocal of impedance is what? Admittance. 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 Take note of that. Take note of that. That means silver has the lowest what? Resistance. The highest what? Conductance. Take note of that. Take note. Then let's go to temperature. You will see question on temperature. You can't escape it. You can't escape it. You will see it. How does temperature affect? Let me quickly explain. And in this video, we might not be able to do question. But in the next video, which should be tomorrow, we are going to do 2 questions on this. 2 questions on conversion of galvanometer to ammeter and voltmeter. Because of, we don't want each class to exceed 1 hour, please. But follow all this formula, please. Follow all this formula. In the next live streaming, which will be tomorrow, before we do chemistry or mathematics, tomorrow we are going to do 30 minutes on 1 questions on this topic. Please take note of that. Thank you. Next one. Next one. Next one. Next one. Next one. Temperature. How does temperature affect resistance of wire? Temperature. Very important. Take note. Take note. Take note. Increase, take note of this. Increase in temperature increases the resistance of wire or metallic conductor. Take note. I'll explain. Increase in temperature increases the resistance of wire or metallic. That's why they say Ohm's law. Ohm's law states that the potential difference across a metallic conductor is directly proportional to the current, provided that temperature remains constant. That's why Ohm's law is like that. Because temperature has effect on resistance of wire. The potential difference across a metallic conductor, Ohm's law, that is Ohm's law, is directly proportional to current, provided that temperature remain constant. Because increase in temperature increases what? Resistance of metallic conductor of wire. Decrease in temperature decreases the resistance of metallic conductor of wire. Metallic conductor, wire. Metallic conductor, wire. That means if there is increase in temperature, the resistance of wire increases. That means it will resist current. Don't forget, resistance is opposition to the flow of current. It will resist current. When there is increase in temperature, the wire won't be able to conduct current. It won't be able to conduct current. But when temperature is low, current will pass through the wire without no problem. The wire will conduct current better when temperature is low. But when temperature is high, the wire will be able to conduct current. There will be what? It will have high resistance. It will be resisting current. Opposition. It will resist current. I don't want current. Why? Because temperature is high. And when temperature is high, there will be vibration of the wire. And because there is vibration of wire, it will affect the movement of electron. Don't forget, what is the current carrier in a meter? Current carrier in the meter is electron. What makes metal to conduct current is what? Electron. Then if temperature increases, there will be vibration of the wire. That vibration of wire affects the movement of electron. It will obstruct the movement of electron. That means the metal won't be able to conduct current. When there is increase in temperature, the wire will be vibrating. Then that vibration affects the movement of the what? Of the electrons. Because electron is the current carrier in metals. Let me quickly write it somewhere for you. Metals. What makes metal to conduct current is what? Electron. Electron. The localized electron. We have semiconductor. Semiconductor. Take note of this. And then we are still going to do the topic. What makes semiconductor to conduct current? That is electron and holes. Take note of that. Take note of that. We are still going to look at this under physics electronics. We are still going to look at that. It's a topic I must teach you. Now we have to teach you. Neotisa must teach you. On this live stream, we have to teach you. Take note. I said increase in temperature increases what? Resistance of what? Of wire. And take note of this. We have what we call temperature coefficient. Temperature. The temperature coefficient of resistance of wire or metallic conductor, which is wire, is positive. Take note, positive. Positive. Why? Because the temperature increases. Since temperature increases, temperature coefficient of what? Metallic conductor is what? Positive. Don't forget, increase in temperature increases the resistance of what? Wire. Since temperature increases, resistance of wire increases. Therefore, the temperature coefficient is positive. Why? Because increase in temperature increases the resistance of wire. Since resistance of wire increases with an increase in temperature coefficient of wire of a metallic conductor is positive. But when we get to semiconductor, the one of semiconductor is negative. That is why increase in temperature decreases resistance of semiconductor. Please write that down somewhere. We are still coming there. Write it down somewhere. For semiconductor. For semiconductor. Write it. Semiconductor. Increase in temperature decreases resistance of semiconductor. Increase in temperature decreases the resistance of semiconductor. That conductor will conduct more current when there's increase in temperature. When there's increase in temperature, semiconductor will conduct more current. But for wire, metals, when there's increase in temperature, there will be increase in resistance. It won't conduct more current. But for semiconductor, when there's increase in temperature, the resistance of semiconductor decreases. That means semiconductor will conduct more current if there's increase in temperature. I repeat, if there's increase in temperature for semiconductor, resistance decreases. That means semiconductor will conduct more current. If there's increase in temperature, resistance of semiconductor decreases. That means semiconductor will conduct more current. But for metallic conductor, which is wire, increase in temperature increases the resistance of wire, metallic conductor. That means if there's increase in temperature from wire is metallic conductor. If there's increase in temperature for wire, the resistance increases. That means the conductivity, the conductance will be low. It won't conduct more current. Take note of that. Take note of that. Please take note of that. Take note of that. And take note, the temperature coefficient of resistance of wire is what? Positive. For semiconductor is negative. Take note of that. 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 Okay, let me rub up this so that we can go to okay, class. That means now you know factors affecting resistance of wire, which are length of the wire, cross-sectional area of the wire, temperature, and nature of the wire. And I've given you the formula that says resistance of wire is resistivity times length over area. Take note, if I make resistivity the subject of the formula, resistivity equal to what? Resistance times area over length. And I told you conductivity is reciprocal of resistivity. That means I can say conductivity. This stands for conductivity. Conductivity, which is reciprocal of resistivity. And the unit is what? Per ohms per meter. The unit of resistivity is what? Ohms per meter. But for conductivity is what? Per ohms per meter. Therefore, the formula of conductivity is what? 1 over resistivity. Reciprocal. I told you reciprocal. That is conductivity with what? If I do the mathematics, resistivity RA over L. Therefore, I will have conductivity. It will be reciprocal. This one go up, this one will come down. That is length over RA. This is formula for conductivity. This is formula for what? Resistivity. Next class tomorrow, we shall do question on them. Let's go to conversion of galvanometer to ammeter and voltmeter in the next 30 minutes. So that tomorrow we have questions on them. Please write this. You can pause it and do that. Please don't forget, Neotisa is here. If you want to learn anything that has to do with software development, UI, UX, cybersecurity, data analysis, don't forget. Tell your friends about the live streaming. We are going to do this throughout the channel. We are going to do live streaming for JUPEP students also. Please take note. Let's move. Conversion of galvanometer to conversion of galvanometer to ammeter and voltmeter. Conversion of galvanometer. Before we move, what is galvanometer? Galvanometer is a device that is used to measure or detect many currents, more current. Write it down. Galvanometer is a device. Is a device that is used to measure or detect small current. Small current. The small current is what? Milliampere. Milliampere. Milliampere or microampere. Microampere. Quickly write it down. Galvanometer is a device that is used to measure what? Small current. That means milliampere. Another name for galvanometer. Another name for galvanometer. Another name for galvanometer is what? Milliammeter. Milliammeter. Take note of that. Another name for galvanometer is what? Milliammeter. Write it down. Another name for galvanometer is what? Milliammeter. Another name for galvanometer. Another name for galvanometer is what? Milliammeter. Let's move. What is ammeter? Ammeter. Please take note of this. Ammeter. Ammeter is a device. Is a device that is used to measure current. You can say large current. Large current. Large current. Galvanometer is for small. Ammeter is a device that is used to measure large current. Large current. Take note of that. And take note of this. Take note of this. Ammeter. Take note of this class. Ammeter is connected. Is connected in series to all appliances. Take note of this. Take note of this. Take note of this. Ammeter is connected in series to all appliances. Ammeter is connected in series to all appliances. It's used to measure what? Large current, detect large current, and is connected in what? Series to all appliances. Take note of that. Let's move now. What is voltmeter? Let me give you the meaning of them so that we go to their conversion straight. Voltmeter. Voltmeter. Voltmeter is a device. Is a device that is used to measure potential difference. Potential is a device that is used to measure what? Potential difference. It's a device that is used to measure what? It's a device that is used to measure potential difference. And take note, voltmeter to all appliances. Take note of that. Voltmeter is connected in parallel to all appliances. Voltmeter is connected in parallel to all appliances. That we have what? Well, we have what we call multimeter. Or let me quickly give you ohms meter. They are ohms meter. This one is used to measure resistance. Ohms meter is used to measure resistance. Ohms meter is used to measure resistance. Ohms meter is used to measure resistance. resistance. You can see it. That is used to measure what? Resistance. Then we have what we call multimeter. Multimeter. From the word multimeter. This multimeter can measure potential difference, can do the work of ohms meter. Multi can do multiple work, can do the work of voltmeter, can do the ohms meter. That is multimeter. But let's move. This is the resistance. I told you voltmeter is connected in what? Parallel. While ammeter is connected in what? Series. Take note of this diagram. Can you see? Voltmeter is connected in parallel to resistance. Ammeter is connected in what? Series. Take note of that. Voltmeter connected in what? Parallel. Ammeter connected in what? If like can put it A here, if like can put the A here, it's still what? Series. Let's move down. Let's go to the conversion. Take note of that. Conversion. I'll just give you the formula. Let's start. Galvanometer to ammeter. When you have a galvanometer, okay, let me have a galvanometer here. This is galvanometer. When you have a galvanometer. Don't forget, I told you galvanometer is what? Milliammeter. For you to convert galvanometer to ammeter, conversion of galvanometer to ammeter, conversion of galvanometer to ammeter, we need a low resistance wire. We need what? A low resistance wire. Low resistance wire is needed. And the low resistance wire is called shunt. A shunt is needed. Low resistance wire is called shunt. A low resistance wire, which is what shunt, is needed. And it must be connected in parallel to the galvanometer. For you to convert galvanometer to what? Ammeter, we need, what do we need? Shunt. What is shunt? Low resistance wire. What is shunt? Low resistance wire. To convert galvanometer to ammeter, a low resistance wire is what? Needed. And that low resistance wire must be connected in parallel. I told you ammeter is connected in series to all appliances. But we are not talking of ammeter here. We just want to convert galvanometer to what? Ammeter. And for you to convert galvanometer to ammeter, you need what? Low resistance wire. Shunt. Is that low resistance wire shunt? That low resistance wire that is shunt, that must be connected to what? Galvanometer in parallel. That means you have this. This is the shunt. Can you see? It's connected to the galvanometer in parallel. Then when you have current, we have small current flowing through the what? Galvanometer. Then large portion of the current will flow through the what? The low resistance wire, which is shunt. This is the current coming. When the current gets here, small portion of it will pass through the what? Galvanometer. Then the larger portion of it will pass through the what? The low resistance wire, which is what? Shunt. Then for we to, this is shunt, low resistance wire, shunt. For we to get the one passing through the shunt, that means we have the total current, which is I, minus the small current, IG. Take note of that. This is the current that will pass through the shunt. That will pass through the shunt. Then from here, we have potential difference of what? Of galvanometer equal to the one of shunt. Then what we have? We have I times G. Small I, that is small IG, times what? The galvanometer equal to this one times this one. Because Vs is what? This times this. Vg is what? This times this. Vs is this times this. That means we have I minus Ig times what? S. Take note of this formula. Take note of this formula. But I like using this formula. I like using this formula. Formula for conversion of galvanometer to what? To ammeter. I like this one. The large current over small current equal to what? Resistance of galvanometer plus shunt over shunt. I like this formula. Take note. I like this formula. I like this formula. Write it down. Write it down. That means the total current over what? Current that flows through the galvanometer equal to what? Resistance of galvanometer plus shunt over shunt. Then I is what? The total current. Small I is what? Milliampere. Small current, milliampere. The current that flows through the galvanometer. Then G is what? Resistance. Resistance of galvanometer. Resistance of galvanometer. S is the low resistance wire, shunt. Don't forget, shunt. S is the low resistance wire, shunt. Take note of that. Please take note of that. Take note of that. Take note of that. Take note of that. That is to convert galvanometer to ammeter. What do we need? Shunt. What is shunt? Low resistance wire. That must be connected in what? Parallel. To convert galvanometer to what? Ammeter. What do we need? We need shunt. What is shunt? Low resistance wire. Take note. And the formula. Take note of that. Another thing. The resistance, take note of it. The resistance of an ideal ammeter. Take note, it's coming out. The resistance of an ideal ammeter is 0. Take note of that. The resistance of an ideal ammeter is what? 0. The resistance of an ideal ammeter is what? 0. The resistance of an ideal ammeter is what? 0. Is 0. Take note of that. Take note of that. Let's move to what? Conversion of galvanometer to voltmeter before we call it a day. Yes, because of time, we need to, before we call it a day, please. We shouldn't be looking at time anymore because this is, everybody must understand, please. We shouldn't be looking at time, but let us manage our time still. Okay, let me rub up this. Take note. Let me rub this one off. Right, conversion of galvanometer to voltmeter. Conversion of galvanometer to voltmeter. Conversion of galvanometer. Conversion of galvanometer to voltmeter. Take note. To convert galvanometer to voltmeter, what do we need? We need high resistance wire. The name of that high resistance wire is what? Multiplier. Multiplier. For conversion of galvanometer to ammeter, we need shunt, low resistance wire. But conversion of galvanometer to voltmeter, we need high resistance wire, which is what? Multiplier is needed, which must be connected, this one in series, this one must be connected in what? Series, which must be connected in series. What is the diagram? When you have this is the galvanometer. The multiplier must be connected in series. Can you say in series? Must be connected in series. In series, you can have it like this, or this one, it can be up. I can have it like this, or I can have it like this. I can have it like this. G, then like this. It's still the same thing. It's still the same thing. Yeah, we have something like this. It's still the same thing. It's still. They must be in series, not like conversion of galvanometer to ammeter. That one, shunts must be in parallel. But for this one, multiplier must be in series. They are in series. This is galvanometer. This is multiplier. They must be in. This is multiplier N. Resistance of multiplier. 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 Take note of that. Resistance of multiplier. Then we have the current flowing. Then for you we have V equal to the current flowing through into, because they are in what? They are in series, G plus N. The current flowing through them, which is what? Small r. Then G plus N. Take note of that. G plus N. Where V is what? The potential difference. I is what? Milliampere. Milliampere, the small current. G is what? Resistance of galvanometer. Resistance of galvanometer. Where R is what? Multiplier. Multiplier. The high resistance wire. Multiplier. That means N. I'm using N. N is what? Multiplier. The high resistance wire. The high resistance wire. Take note of this. Take note of this. Then take note. And the resistance of an ideal voltmeter. Take note. Voltmeter is infinite. Is at infinity. Take note. The resistance of an ideal voltmeter is what? Infinite at infinity. The resistance of an ideal voltmeter is coming out, is coming out. You can't see it. Is what? Is at infinity. For ammeter, the resistance of an ideal ammeter is what? 0. The resistance of an ideal voltmeter is what? At infinity. Take note of that. Take note of that. Take note of that. Let's quickly talk in the next 3 minutes or 4 minutes. Let's quickly talk on sensitivity of ammeter and voltmeter. I'll just give you the formula. The sensitivity of ammeter and voltmeter. I said tomorrow will be question on this. Will be question. Let me run it off. Let me run it off. I say sensitivity of ammeter and voltmeter. Sensitivity of ammeter and voltmeter. Sensitivity. Take note. The sensitivity of ammeter is what? Angular deflection over what? Current. Take note of that. angular deflection over current. Sensitivity of ammeter is angular deflection over what? Current. Where SA is what? Sensitivity of ammeter. Sensitivity of ammeter. Theta is what? Angular deflection in degree. Angular what? Deflection. Angular deflection. I is what? Current. What is sensitivity of ammeter? The ability of the ammeter to detect small current. To be able to detect small current. Sensitivity of what? Ammeter. Take note of that. Then take note. Sensitivity of ammeter is inversely proportional to internal resistance. Internal resistance. Take note. You have to know that. Sensitivity of what? Ammeter is inversely proportional to what? Internal resistance. Let me quickly give you the one of what? Voltmeter. Sensitivity of voltmeter is what? Angular deflection over what? Potential difference. In this case, potential difference. That what is sensitivity of what? Of voltmeter? The ability to detect, to be able to measure small current. Take note of that. Where SV is what? Sensitivity of voltmeter. You know, theta is what? Angular deflection. V is what? Potential difference. This one, sensitivity of voltmeter is this one is directly proportional. I'm sorry, it's directly. Please change it, class. Change it. This one is directly proportional. This one, sensitivity of voltmeter is inversely proportional to internal resistance. This one is directly proportional. Please take note of that. Please change it, class. Please take note of that. Next class, which will be tomorrow, we are going to use 30 minutes to solve all questions on this topic. Please don't forget to subscribe. Tell your friend to tell your friend to tell your friend. Please subscribe to the link. Then if you want to learn anything about what, visit www.neotisa.com. The web app will be upgraded very soon. Visit it, tell so many people. If you want to learn software development, UI/UX design, cybersecurity, and data analysis, then don't forget, learn the future skill. Then when you are talking about JAMB, WAEC, JUPEL, 100 level, don't forget, we have one name. That name is what? Neotisa. Thank you. I remain myself, JAMB. We are 2 or 1 hour.
Hours.